Welcome to our lab with Engineering Tomorrow. We are going to be talking about networks today, and I am so excited to be on this journey with you. So let's jump right in. What do you think that it means to go viral? And also, how does it happen? All right, if you said something about social media platforms, you are right on. So, whether it be Instagram or TikTok or Facebook, one of the ways of going viral these days is when many different people end up resharing your content. And so, going from one person to the next is very similar to what we will be talking about in our network lab today. So, let's get started. Are you wondering who I am? Well, let me introduce myself. My name is Betsy Fortman, and I am an aerospace engineer. As a toddler, I was always very curious about how everything around me worked. I took things apart in our house. I took apart our phone. If you've seen other labs with Engineering Tomorrow, you probably remember me talking about how my mom had to hold the car door shut when I took the car door apart and drive us home. So I took apart so many things. And nowadays, I know that means reverse engineering. But I wanted to use my curiosity for something bigger than myself. And I decided very early on that I wanted to join the space program. So back in the day, we didn't have the internet, and I just started researching different colleges. I don't know if that's where you are in your journey right now, researching colleges. But I looked for a college that was really good at engineering and then one that had a lot of space astronauts that had come from them. I figured if they had astronauts, that it probably had a pretty good space program as well. And so I wanted to be a part of that. I joined Purdue University, where I studied aeronautical and astronautical engineering. Some different universities may call it aerospace. That's all fine too, no problem. Aerospace, aeronautical, astronautical, all the same discipline. And you can see that in my Purdue box, I also have something called NASA Langley Research Center. I put this in here because as I was in college, I did something called the Cooperative Education Program. And this allowed me to go ahead and start working as an engineer right away while I was still in college. If you've ever sat in a class and wondered, why is my teacher telling me this? I was right there with you. I remember my professors explaining all the aerodynamic equations and forces that were affecting how the airflow went across a different airplane wing. And I was like, I know this is important, but I'm not quite sure how it all fits together. You guys, being a part of the co-op program allowed me the very next semester to get to see the engineers and the technicians placing the sensors on the F-18 model. And then we were wind tunnel testing it right after that to see how it controlled some of the buffing and effects and things like that. So if you ever have a chance to do any hands-on learning, whether it's during your summers or a part of a co-op program with your university, I highly recommend it. It really helps solidify like why you're learning something and then how it applies. It also helps you learn kind of the things that you really like to do and those that maybe you want to just get through and get to the next subject. So that will help kind of narrow down your career path as well. When I graduated, I really loved working with NASA, but I still had this very big desire to work in the space part of it. So I went down to NASA Johnson Space Center. That's the one down in Houston. So if you've ever heard that term, Houston, we have a problem. That's mission control. It was my job right out of college to start training the astronauts and the flight controllers. So those people sitting in mission control, how our guidance, navigation, and control system work. So like how we're oriented with respect to the stars, how we're performing reboosts, or perhaps doing a docking with a vehicle that was coming in. So I've got to do a lot of wonderful work with our training team as well as our astronauts, helping prepare them for flight. As a part of this job, I also traveled to Russia, where I helped teach the astronauts and the cosmonauts all the different systems for the space station on the Russian segment. So how we, cool the different systems, how we communicate to an astronaut doing a spacewalk, how we distribute power out to the fans and computers and all of that. When I came back from Russia about 6 years later, I joined the astronaut office as their chief engineer for exploration, which meant I got to help analyze the designs for everything that was coming after the space shuttle. So things like Artemis or the vehicle that is going to the moon and Mars. You may have heard as I'm recording this, it just finished up its first flight, going on a distant retrograde orbit of the moon and back home. And soon we will be putting astronauts on it for the next flights coming up. So exciting. On the bottom right, you can also see that there is SpaceX and Boeing. So I was helping lay the foundation for our commercial crew programs and kind of setting up that human rating aspect for their different vehicles as well. So that's me in a nutshell. This lab you can see was created by a team of engineers. On the left, you can see Edgar Martinez. He was our lead engineer. And then we had a group of college interns and mentors who also helped in developing this lab. We want to make sure that all the labs have content that's relatable to what you will be learning in college, and also helpful to the content that you'll need to know as well. So you can see there Kira and Julian and Gigi as well. If you are thinking about going into engineering, remember Engineering Tomorrow when you are in college, because we do hire college interns and mentors to help conduct the labs and to kind of give back to those high school students along the way as well. So keep that in mind. All right, so today, what are we here for? We are going to be talking about networks, and not only networks, but you guys are going to get to code a drone. How awesome. So part one, we're going to just talk about the theory of networks. What is it and how are they created? And then I lump parts 2 and 3 together. We call it the traveling salesman problem. Basically, it's trying to find the most optimum path or solution for a given problem. In our case, it will be a person traveling and delivering different equipment, but it could be, any kind of function that you might need today, whether that's you traveling, whether that's you sending a package, maybe you have to go make deliveries for shipped or something to that effect. And so knowing the best path. And then lastly, once we get our best path of how we are going to go from our parts 2 and 3, we're going to apply that to our drone and then code our drone to go make those deliveries. So let's check it out. Are you ready? Let's go. Part 1, networks. What are they, right? We all talk about being on the network or being on the internet. So if you have ever done that, which I think most of us have, you are using a group or system of interconnected things. So by the internet, you are connected to the different information sources that can feed that back to you as well. Networks have so many applications these days. They are found in our brain and connecting the different signals. If you think about just the fact of if you want to touch something, how your brain will take the information out from the nodes or your fingertips and know that, hey, that's hot. I shouldn't be touching that stove. And it feeds that information up through the various nodes to your brain. Your brain figures out what to do with it and then sends the signals back down so that you move your arm out of harm's way. You could also imagine the various different Amazons and other companies that are delivering products. If you are waiting for some kind of product, maybe you need a new cell phone, or maybe you need a new piece of football equipment or something to that effect. You might go out on Amazon, research it, and decide that you're going to order it. Well, guess what? There may be like 4 different types of whatever you're looking for or more. And all of those things are networks. So which one are you going to choose? And then how are they going to get that piece of equipment back to you through the networks? So that will be part of what we're looking at today as we look at our traveling salesman. And then over here on the upper right, you can see the United States. It looks like this is a system of maybe railroads or something to that effect. But you can imagine even airlines or other different ways of connecting our country, or maybe it's our interstate systems that will take you from one place to another. And that's another example of networks. And then lastly, AI. You may have heard this as artificial intelligence. I find this such a fascinating area. So, taking that information as we started talking this slide and looking at the brain and how our brain functions, but then applying it so that we can code computers to start doing some of that learning on their own. The way that you can, ask Alexa to play a particular song, or maybe you want to see a certain funny cat video and you say, Siri, give me funny cat videos. And it shows you, maybe it gives you a list of all the different types of cats, or maybe it will show you different ones where the cat's jumping, the cat's playing on a piano or something to that effect. So there's various different ways that it will give you this information and then you can choose. But artificial intelligence, it will kind of help start making those choices of like what information to feed you in order for you to make that final choice. So cool. All right, so this video here, we're going to take a look at. It will show you a little bit more about what networks are and how they form.
What does going viral on the internet really mean? And why does it happen so quickly? Why is a financial institution too big to fail? How does a virus in Africa end up in the United States in a matter of hours? Why are Facebook and Google such powerful companies at creating global connections? Well, in a word, networks. But what are networks? Everyone knows about their social network, but there are all different kinds of networks you probably haven't thought about. Networks are collections of links which combine by specific rules and behave as if they're alive. We say that networks are alive because they are in constant change. Over time, the connections within a network migrate and concentrate in new places, forming evolving structures. How the evolution and concentration of constantly changing connections occurs is the subject of a whole discipline called network theory. We can think of networks as neighborhoods. Neighborhoods are defined by maps. A Google map demonstrates the relationship between locations in exactly the same fashion a network connects hubs and nodes, using streets as links to connect neighborhoods. The reason a network can expand and evolve so quickly is based upon a mathematical concept called power functions. A power function is a mathematical amplification mechanism which over specific and very small ranges accelerates changes logarithmically. That is, a very small change in one parameter produces a huge change in another over a very specific range of values. An example of how network structure emerges is the algorithm used by Google. As the number of links around a search term, say friends, increases, connections begin to form among millions of different searches using the term friend. What Google has cleverly accomplished is a real-time mathematical model for how to predict the emergence of growing connections among billions of search terms. The algorithm Google derived collects the number of references to any search object. As references to a search object increase, the number of links also increases, creating a node. As the node increases in size, it eventually becomes a hub, which links to many nodes. Networks will continue to emerge as new ways of connecting and creating neighborhoods are defined. Perhaps you can begin to see why networks are so powerful. As Google continues to collect the billions of daily searches, new clusters of links will rapidly emerge, forming additional and growing networks. Despite the logarithmic expansion of your network, the laws of 6 degrees of separation still apply. Therefore, if you explore close friends or acquaintances in your Facebook network, everyone on average will be separated by 6 individuals or less, and the map of your social network will create neighborhoods linked by common connections among friends.
Welcome back. I hope you enjoyed that video. It does a wonderful job of explaining just how those networks are forming, but not only are they forming, but they're constantly changing, which is so amazing. And the fact that, we can change our networks as more information is added, as more friends are. If you have a particular Facebook page, maybe you have 25 friends, and those friends have 25 more each. And you can see how quickly something becomes a bigger network, just like that video showed. All right, so let's talk about some applications of network theory. Over here on the left, we've already talked about a lot of these, but like scheduling and delivering. So if you were the company of Amazon or FedEx and you're trying to get your package to your person as quickly as possible. But you guys, with gas prices these days, you might also want to take the most effective route, right? You don't want to be wasting fuel to get it there quickly. So, you may be factoring that in as well. But then also, I have heard places like, or the apps like Waze and other ones are actually looking at giving you paths and driving routes, if you will, that will have a reduced carbon footprint too, so that you could take, what is the best for our environment. Um, Airline route planning, that's another one. If you think about the airlines, so they not only have to figure out what city they're going to fly from and the fly to, but how many passengers are going to be flying at a given time, which routes are the ones that we should be taking, which ones should we not be flying anymore. But also there's so many other different things that affect the airline routes, like the air traffic controllers, um, how many different airplanes are actually nested, or what we would say, docked at a gate. If I need that gate, is it going to be open for the next plane that needs to come in if I'm occupying it, and things like that. So how we coordinate who's at what gate, who's on the runway, who is, backing from the gate and getting ready to go to the runway. All of those different facets to help optimize our efficiency. Computer and electrical and social networks. So imagining all the different networks that are out there. So, how we're connected on Facebook, or maybe if you write something in Facebook and it's popping up in another social platform. All these different networks of connectivity of information are what we're looking at in this particular lab. One that I don't always think of, and this one has to do with the spread of infectious diseases. This is also an application of network theory. So, thinking about how someone in Africa can get sick, and all of a sudden, a few hours later, someone in the United States has it. How did that happen? What are the paths that it's getting there, and certain things like that. With COVID, it's also in the forefront, I think, these days of that network theory. Like, where did they go? Who did they know? How did it spread? So being able to track certain things like that, as well as kind of predict and say, if it's here, we may need to start deploying people in a neighboring town, or start having and building up certain rescue units in neighboring towns, or wherever that network may grow to, if that makes sense. And then lastly, our brains. So just the way our brains function, how that information can travel from one place to another. It's so fascinating to me how scientists and doctors these days are able to map certain areas of the brain and understand, how maybe a dyslexic brain will send information through one path, and how a non-dyslexic brain will send it a different way, and just all the facets and how our networks form their own networks inside themselves. So, some of our grand engineering challenges, if you've ever heard of them, reverse engineering the brain. So, studying how it's doing that and then being able to replicate that. Cybersecurity. This is a big one these days, right? We want to make sure that we understand what kind of terrorists may be out there trying to contaminate our water supplies. Or perhaps, I don't know if you had heard, but there was a terrorist cell that had claimed responsibility for actually shutting down some of our pipelines and things like that. So being able to predict that, and then knowing kind of their next step, like knowing what they're going to do next, so that we can prevent those things from happening, as well as any type of nuclear terror or criminal attacks on our country as well. So let's jump right in. Remember, I was saying parts 2 and 3 are going to be that traveling salesman. I'm going to lump them together for you, because all of the information that we get from parts 2 and 3 will then be applied to creating our drone. So let's jump right in. Imagine you are this traveling salesperson. You don't want to be on the plane forever, right? So, but you want to get to your places that you have to go, and you want to do it in the quickest way possible. So you can imagine that you're going to travel from all these different cities. And this is part of your drone as well. So this map will become familiar to you as we work through our lab here. How are you going to go? Which city should you start from? And do you need to return to it? Or do you just want to get to the end? So all of these are going to be questions that we start looking at today. There will be an online simulator. It's called the TSP. It's short for Traveling Salesperson. And we'll use this today to kind of help enhance our understanding of these networks and then how we can optimize our paths or ways of traveling. And so you're going to see here, this in your workbook will be laid out for you. There'll be links of where you need to go, but I will help kind of show you along the way of what you're going to be doing. That way, when it comes time for you to go into your workbook, you'll already kind of have seen this and know exactly what you're going to be looking for. Welcome to the Traveling Salesman Problem. So as we jump into this particular tab, you will notice that we'll go to create a game. Up here, you have the different selections of Africa, Italy, and the Netherlands. I know it looks like it's written a little bit funny to us, but I believe it was created maybe in Germany. Don't mind that. Just go ahead and select one. I'm going to go ahead and select Africa for us. And then next, I'm going to set it at 6 cities. You'll see why in just a second, because as it chooses our cities, we want to make it start low enough where we're going to be able to find the solution and then add more nodes as we go. So let's get started. Let's hit start game. You'll notice that it will show you different cities. Now, everyone's going to have a different map, even if you select 6 cities and Africa as well, and you're doing this right along with me, you'll notice that the computer will randomly generate the 6 cities. So go ahead and start clicking them where you think it's going to be the optimal path. I'm going to just kind of go on the outskirts. And you can see there, I've gone back to my number 1. And let's see, my length of my tour on the right-hand side is showing up at 13,086.4 kilometers. Let's see if that's right. So you click show solution and guess what? Yeah. So in this case, I did guess the optimal solution. It'll show you your tour and then the optimal tour as well. And so the difference between that is what you're going to be looking for in your particular area to tell if you hit the optimum or not. All right, so I'm going to go back and do another game, but this time in your workbook, I believe you have to do 6, 12, and 20 different nodes. So I'm just going to select 10. I want to show you what happens as we start entering more and more. Okay, so let's just go ahead and start. You can see there's a lot more cities. It didn't give me the same ones. And the quicker I go through and try to guess our optimum solution, hopefully I've got it, but I don't know. We'll go ahead and see. So show a solution. Oh, looks like I did get it at 10. I bet if I did it at 20, I wouldn't get it. So I'm curious. How's it going to go for you? Are you going to get the optimum solutions or not? Good luck on that one. As I jump back to our presentation, I'm just going to show you where you're going to put this information in your workbook. So let's check it out. In your workbook, on the bottom here, you can see this chart that you'll be filling out. So number of 6 cities, we can say, yes, I hit optimal. But for you, I don't know if you did. You probably did, I'm guessing. And then you'll list your distances right in here. As you get more, so when I hit 10, I did good, but I think around 12 or even 15, I'll probably not get it. So you'll have to go ahead and just fill this in, just chunk the information in as it's happening. What was your tour? What was the optimal tour? And then how far off are you? So this is the difference between yours and the optimal solutions. As you're doing this, I'm curious, what city are you going to start with? Are you going to start with the one on the furthest left? Maybe you want to start in the middle. As we start getting more and more cities, it starts getting harder, right? Did you notice that when you got up to 20, that it did start getting more and more difficult to find the optimal? Checking here, we're going to start looking at the traveling salesman problem again, and we're going to look at the different cities. We're going to call these nodes. You'll see here that when we blank out the world behind them, if you will, that it just becomes this connection of nodes, right? It looks like some paths. We might call this the graph of our solution, and then the red dots are our nodes. When we have the number of paths for 3 nodes, so you can imagine it's pretty easy. There's one sequence, and you can't go wrong, right? So I like that one. When we start going to 4 paths, all of a sudden there's more sequences that we could choose. So it gets a little more difficult to get that optimum. And then what if we go 5? Look at this. If we just have 5 cities, there are 12 different ways that we can go. And that starts becoming a lot more difficult. So as we add more and more nodes, we're going to see this path of nodes down here on the very bottom. That equation becomes this factorial of however many nodes we choose. So n being the number of nodes minus 1 to the factorial. Now, you may be having flashbacks from math class. Don't worry. If that's a 5, you would say 5 minus 1, which is 4, and then 4 times 3 times 2 times 1, and divide that by 2, because you're going to go from one node to the other, and that will be the number of paths. So you can see from 5, we go up to 12 different sequences. And then lastly, if you start looking at 9 and 10 and 20, the paths start going very, very much what we might even consider viral, right? So 20,000 for 9. And then look, we're up in the millions for 12 different nodes. That's incredible. All right, so solving our traveling salesman problem, or the TSP. These are going to be our different cities that our drone is going to go from and to. And we're going to try to determine what's the best method to do this. Well, I don't know about you, but sometimes just seeing the different distances can really help me narrow down where I want to go next. And so this part of the lab will have you lay these out in a matrix. We're going to go from Seattle to LA, Seattle to Denver, Seattle to Minneapolis, and you can kind of see the pattern here, right? As you're laying out this information, you're going to use a website. But what you're going to be doing is finding the city that you want to go to, Seattle to LA, right? And then you calculate the distance. All right, so there is our distance. If we're driving it or if we're just flying. In our case, our drone would be flying, so we're going to grab just the straight distance, right? And we can copy and paste that information straight into our matrix. Now, as you can imagine, this is going to take a little bit of time, right? The good part is that being a matrix, the distance from Seattle to LA is the same. So this little block here is also the same as LA to Seattle, right? So you can fill in 2 blocks with one try. So just make sure you know where you're filling the information in and then put it in its sister block. So you would also do this and just start filling this in. If you're doing this with a partner, you may want to divvy up like which cities you're working on to help fill in this chart a little more quickly. Now, once you have, okay, Seattle, all my columns are filled in, LA and Denver, you can look at these kind of as a separate column itself and say, what's the closest thing for me to fly from Seattle to? Okay, and then once you know what is the closest thing, you can decide to fly there. And then once you know what city you're in, you go to its column and say, what's the closest thing for me to fly next? And you can go down the path that way and try to figure out where you're going to send your drone next. And that's the whole goal. We're coding our drone, right? So we want to make sure we're flying it in the most efficient manner. So we'll fill this in. And then you will see your matrix filled in here. There is also something that you can check it against. So this is really cool. On the screen on the bottom right, you can see this kind of grayish red solution matrix here. Once you have your matrix, you will pull up this particular website. Now just ignore all of these different ads. They come up regardless, and you'll enter your matrix size. So in our case, do you remember our matrix? So we're going from a 9 by 9. That's what we would type in. And so you would say 9 by 9, and you type that in, And now on the top, you'll have J1, J2, J3, etc., M1 and 2 to M9 on the left-hand side. These are our cities, just like you saw in your workbook. So in your mind, just substitute whatever city that is. You're going to type in your solution for your matrix here. When you do this, the really cool thing, you guys, is it will tell you what the optimum method and pathway is. It'll say, oh, start at node 1 and go to node 5. Start at 5 then and go to 3. And then from 3, go to 2 and then 2, 4. You can't just copy this because obviously in our workbook, we've only given you a 5 by 5. Your solution is a 9 by 9. So you'll have to figure out what that path is for you. But once you do, then we use that information and go ahead and plug it in for our drone, which is so fun. So as you're breaking out into your groups, consider who's going to be recording the answers and also where you're going to fly. And the next part, when you know how far you have to travel, I would say, let's begin with the end in mind. I think a really smart guy, maybe it was Stephen Covey, had said that. If not, I'm not exactly sure. But we want to know, how much is this whole process going to cost us? With end in mind, we can try to minimize how much money we're spending to achieve our goal. So we're going to say that we are spending 5 cents per mile. That's a pretty nice estimate. It's probably on the low end on these days, but we'll use that as our gauge for how much we're going to spend in general for our flight. And then we'll test it out. All right, so jumping right into part 4, this is my absolute favorite part of this lab. And that is that you get to code a drone. But before we do, I'm super curious. What is your favorite drone application? Is there one that you like best? So I will share with you some of my very favorite drone applications. I'm curious if they ended up being the same as yours. So my absolute favorite is this flight of ingenuity on Mars. This is a helicopter drone on Mars. The last I checked was September of 2022. It had flown 33 different flights, completely autonomous on Mars. Isn't that incredible? So that's my very favorite drone. Here is another one. This one blew my mind, you guys. I was at a swim meet at a university, and I'm actually, you can kind of see this video here. I'm at a stop sign, and this little drone is like a tiny mini car, and it is delivering things to students across campus. And it even stopped at the sidewalk and waited for me. I was totally amazed at how that was able to do that. So I don't know if you guys have seen these. If you have some nearby you, I can't wait to hear. All right, so let's take a look at some applications of drones and see if we captured any of the ones you guys were thinking of. So weather forecasting, being able to send our drones into areas that maybe have tornadoes coming or things like that without having to put humans in danger. Such a help. Obviously, on the right-hand side, you can see over here, disaster management. If there is a particular building that has collapsed or maybe it's unstable, they can now send drones inside to find where the human beings are located to direct our rescue teams straight to where the people need rescuing. How incredible. I love the use of technology and how it is just exploding these days. Geographic mapping, being able to, not only see things from space, but also those that are underwater. You can have drones that are like submarines that can go and check out the wildlife, but also map the different areas to the lowest levels of the oceans these days. We've talked a little bit about wildlife monitoring and how we don't want to interrupt their processes and how they're living, but sending a drone in and having it camouflaged with their environments can be a super helpful way for us just to be able to understand our wildlife and their habits more closely. Shipping and delivery. Obviously, you saw the one video of that university where they're using the drones to be delivering different objects and items to the students. Entertainment, you guys, these days in Hollywood. So if they're trying to do like a really interesting photo shoot or video shoot, they can send the drones in to go at certain angles within the different scenes to actually capture those videos now. It's just incredible. And then lastly, I didn't mention is agriculture. So being able to have your drones sense like how much water has fallen in a given area and to feed that information back so that, we can water it more, or if we know we need to change the soil in a different way, are all different ways that our drones can help. And then lastly, you can see this cool image using infrared imaging of solar modules. This is one of the areas that I thought is so cool. Some of those big solar farms these days are, miles and miles long. And trying to locate the damage and sending out people to walk on foot to be able to find that damage is not only timely, but costly as well, right? You can imagine. And then maybe not even detecting where the problem is. But using a drone that can go out and use infrared, they can immediately find where the problem is in the given solar panels and then go and deploy the team to fix it right away. So amazing. So today, here is your lab and what you'll be doing. You will be using Scratch. I think a lot of you are probably familiar with how it works, but we're going to use it slightly different today. So you'll notice on the right-hand side in the upper area, there's a drone, right? And you see our cities. These are the same cities from parts 2 and 3 that you just calculated with your matrices and figured out our optimal path. So it is your job, if you choose to accept it today, to code your drone to go to each of these delivery areas. What you'll do, I'm going to go ahead and stop sharing this screen and switch over to Scratch. Here we are in our Scratch window, and you can see it always defaults with this little cat. You probably have seen this in your other times. We're not going to be using the little cartoon cat today. Instead, we're going to jump right in from our file location, and we're actually going to download it to our computer. I've already done that step for you, but I just want to show you what it will look like when you bring up your drone simulator. Okay, so once I've loaded it, see how quick that was? You can see our drone starts in the center. So depending on what you found from your different TSP locations is what you're going to start with. So if you decided you're going to start here, then you're going to start coding your drone there. Now, I like to use the glide function. I can use that as I need, and notice that you're starting at 0, 0. I believe every single one of these particular hash marks is 20. So you will then have to figure out what your X and Y coordinates are for each of the cities that you've laid out in your TSP, like the order that you want them to go at. And then I'm just going to throw some in here, just one for now. 20, 40, 60. Let's go -60. And you can just type your coordinates straight in here and 0, right? Because that's just all I need. And you can see here. So that made my drone move to that specific site. If you had typed in a different number, let's just try 40 and 100. I don't think this matches up to anything. I'm just showing you kind of logistics. Whenever you click that flag, it will then fly to those numbers. Hey, I was not that far off. Super. So as you are coding your drone, you're just going to keep continuing this pattern. So you'll just bring in more and more of these. Put a delay in there depending on how long you want to be waiting at each of the different cities. I believe it's in your workbook. I usually go anywhere from 2 to 5 seconds just to make sure I'm at the right city before I head it on to the very next one. And then once you are done, you can go ahead and record it. We would love to see how your drone flies throughout your TSP problem to each of these different cities. So good luck on this part. I think you're going to really enjoy it. It's one of my favorite parts of this lab. Okay, now that you have the gist of how to code your drone, I'm just going to give you a couple more tips. These are all listed inside your workbook. Again, you'll be using the file that you'll download. It's called dronesimulator.sb3, and you'll click on the upper left-hand corner of Scratch and load to your computer, just like you saw. It doesn't take hardly any time at all once you have it downloaded. It will look like this screen on here. You'll use the green flag to be your starting, signal for your drone to start going through its code. And you'll see the preview window over on the right-hand side that will show how your drone's flying. A couple things. Most of these I showed you already, but the one I forgot to show you, and that is the wait X seconds. So you can use that in between each of your locations of the X and Y coordinates to help kind of break up going from city to city to make sure you're at the right city. And you'll use the glide function or the go to function to do those things. Looking on your screen, X is just like our normal X and Y coordinates. X goes to the right from our very center, and negative X goes left. Going up is your Y direction, going up is positive, going down is negative. And you can see inside your workbook, it will also show you this, but just as a reminder, each block is 20 steps in Scratch. So when you're trying to figure out your location, if it is, 11 blocks, then that is 11 times 20. So keep those calculations in mind. And I think you're going to breeze right through this. And I bet you're going to love coding this drone. If you liked today's session, you may consider going into areas such as artificial intelligence. It is really growing more and more these days with all the different computer systems and other ways of connecting our world. I really feel like artificial intelligence will only get bigger. Data science and applied mathematics, drone delivery systems, as you saw at that university, if it's happening at universities, it's probably going to start spreading to all over our country in that way as well. And neuromapping of the brain. I find that the human brain is so fascinating, and we are constantly learning more and more about how efficient it is at making decisions. And then on the right, you can see the engineering areas. Industrial engineering is all about taking a process or taking an engineering area and trying to optimize it, which is exactly what this lab focuses on. Computer science and all the coding that goes into it. Systems engineering, getting it all to coordinate together and controlling it with controls engineering. And then operations research, just understanding every piece of the process and what has to happen. Like even those minute details that might seem to us minute, like how many airlines are at the gates at a given time, and making sure that they free up when the next plane comes in. All of those things are part of the operations research as well. I want to leave you with one thought, and that is from Richard Branson. I just love this quote. It is, "There is no greater thing that you can do with your life and your work than to follow your passions in a way that serves the world and you." And I know you may have seen this in some of our other Engineering Tomorrow labs, but I love to share it every time. For me, that is exactly what we're doing. Find what you love and then use it to help make everyone's lives better. So cool. So I hope you enjoyed our lab today. On behalf of Engineering Tomorrow, enjoy coding, and I'll see you soon. Bye.